Okay, I'll sir.
I once again welcome all participants for the second session today. Mr. Ponnu, Mr. Ponnurangam, Vice President, Head, Wind Research Ever Renew Energy Private Limited. He is going to talk on the topic wind energy yield assessment and energy storage system. So in this, mainly he is going to concentrate on what are the wind resource assessments are available and wind flow modeling and measures correlate predict MCP and energy production forecasting. And also is going to talk about battery energy storage system, pumped hydro system, pumped storage system, compressed air energy storage system, flywheel energy storage system from wind energy by using wind energy. There is a different topic. I think we are all going in the right direction according to topic given in the FDP, energy conservation, storage, global sustainable development. I think all parties can enjoy like anything. So in this line, our Ponnurangam, once again welcome you Ponnurangam for this wonderful FDP program. Mr. Muhammad Hanif, please give please give introduction about him. Mr. Muhammad
Yes, sir.
Hanif, yeah, please.
Yes, sir. Thank you, sir. Thank you, sir, for giving me an opportunity to introduce our speaker, Mr. T. Ponnurangam, sir, Vice President, Wind Farm Solutions, Avenue Engineering Energy Private Limited. Sorry. Welcome, sir. Mr. Ponnurangam, sir, is a technical professional with over 29 years of work experience in the energy and aerospace industry and had spent the last 25 years in the renewable energy sector. He is a graduate from IIT Madras in aerospace engineering. Under his leadership, he established a complete set of wind research activities, starting from identifying wind potential sites, wind measurement, wind resource assessment, site development, energy estimation, till energy yield proposal from the company to investors. In his renewable energy career, a successful assessment of 20,000 megawatt feasible wind potential sites through measurement campaign across India during his tenure in Siemens Gamesa and Vestas India. In his credit, he has supported for successful completion of 11,500 megawatt wind farms development at Siemens Gamesa and Vestas by managing clients, coordinating with cross-functional teams, developing partnerships, and building positive rapport with teams and state nodal agency. He is an effective leader with proven abilities in leading teams, dedicated, hardworking individual with intercommunication skills to work at all levels of organization. Currently, Mr. Ponnurangam, sir, is heading wind research at Avenue to support the entire wind value chain in EPC and C&I solutions and setting up systems and processes to achieve a scale of 5 to 6 gigawatt scale in the next 4 years. Now, thank you, sir. And now I hand over our sessions to our speaker, Mr. Ponnurangam, sir. Sir, your mic is yours, sir.
Yeah. Thank you. Thank you for your nice introduction. Good evening, all, and it's my pleasure to meet and interact with you all through this program. And I thank Professor Dr. CHINNAPANDIAN for giving me this opportunity to interact about the wind farms, especially renewable energy, especially into wind farm development and the energy storage system. So I have put into two parts. One is the wind resource assessment, the energy estimation part, and then energy storage, because yesterday I too had attended one session which had covered, the guest had covered the energy storage system, and there are some more sessions the coming days. They will be covering the energy storage system. So I thought I'll give some insight into the wind farm development. So that would be useful information to you all, I hope. So let me share my screen. Okay, fine. The title of this this short session is Wind Energy Yield Assessment and Energy Storage System, Battery Energy Storage System. So I just want to give more details about the wind farm development and into specific what I do in this industry. Actually, what I did for the past 25 years in this industry, renewable energy industry. So I thought I will I'll take more time on that, and then I'll cover the energy storage system also at the end of the session actually. So mainly, what is a renewable? Why people are rushing to the renewable energy? And now the battery or the storage system also, mainly because to protect the environment and the mother earth from the we all know that the pollution and the gases emission, all these. So that's why most of the countries are completely moving to the renewable energy, so that they can be free from the pollution, environmental pollution actually. So why mainly we are moving to renewable energy? Because the sources, the raw material is available, abundant, at free of cost, and also it has no negative impact by using the renewable energy sources. And the natural sources like wind, solar, geothermal, biomass, all these are used to generate electricity. Mainly wind and solar is the predominant renewable sources used most of the industry actually. And then unlike fossil fuel, renewable energy sources are available continuously and replenished through natural process actually, making them an economically viable energy alternatives. Because we are nobody is doing anything actually. It is available 24/7. The sources are automatically regenerated actually. That's the reason maximum people are moving towards the renewable energy source to generate the electricity. And wind and solar power are the most common actually across the globe. And as per the potential assessment in India, so it is calculated something around 1150 gigawatt. Out of this, at 150-meter height level, at this are all gross level. Out of this, 500 megawatt is the government target to achieve the energy generation through renewable source. This is the Indian scenario, so I want to give you some details. MNRE is committed to generate 500 megawatt of renewable energy, 500 gigawatt of renewable energy power by end of 2030. So we have another 6 years down the line to generate. Out of this, 210, somewhere around 210 gigawatt already the commissioned until end of 2024, and another 290 gigawatt to be developed by 6 years time actually by 2030. So there are a lot of opportunity for the employment as well as the business in terms of business opportunity, because government is very serious to develop this 20 to achieve this 290 gigawatt. May not be even by 2030, maybe it may take another 1 or 2 years more also. So government is very eager, and they are giving all the support to the industry, whatever the possible by them, and whatever the industry need, investors need. So this is the main thing we have to see for the next 6 years actually, and the opportunity actually. And again, we are in the fourth in installation of renewable energy after China and USA and Germany. So both wind and solar also we are on the top, in the top slot, this one actually, the fourth place. And now government is exploring offshore wind farm development actually. So they have conducted a test along the Gujarat coast and assess the potential. And in another area, Tamil Nadu coast, Tuticorin belt up to the Kanyakumari, they have studied, and they are just exploring. They are exploring next to the offshore wind farm development. We were in the field for the last more than 30 years. I think 1990 to 2024, more than 30 years. We are excelled in wind farm development. In the last 10 years, we have done a wonderful development of solar project, almost 100 gigawatt. solar project, and 50 close to 50 in the wind actually. So now they want to focus the offshore wind farm development also, because we have a very long coastal area, and the potential also very high in the Tamil Nadu belt. These are the government the targets in the coming years. The installed capacity, if you see that the wind alone, I'm saying, Gujarat is topping the installed capacity with the 12,400 megawatt, and then next Tamil Nadu 23% with 11,300 megawatt, Karnataka 6,800, and Rajasthan, Maharashtra each 5,200 megawatt, like that, in that range actually. So somewhere around 50 close to 50,000 megawatt we have already installed, close to 50,000, 48,000 something, out of targeted 50,000, 100 gigawatt. So this is the a very significant information actually. Last year the government has done a wonderful thing. Industry has supported very well to perform in the solar development, close to 24.5 gigawatt across the country, and the wind of 3.4, and thermal the conventional energy 4.6, biomass 1, and solar 0.7, put together something around 33.5, 34 gigawatt last year achieved. That is the highest ever actually in the past actually. So this is last solar and wind installation. So now we are close to 100 gigawatt in solar. Last year they have done now 48, close to 49,000 gigawatt commissioned till end of December 2024. This shows that a very ambitious plan of the government actually, and clean energy, especially into clean energy. So I just want to give just small animation actually. Yeah. So you have seen the small animation. Just I want to show that how some of you might not have seen the wind turbine workings and functioning. How the wind turbine now works. Just to show that wind turbine obtains its power input by converting the force of the wind into torque acting on the rotor blades. So you have seen some slices passing through the rotor disc. So whatever the slice, the number of slices passing per minute, so depending upon that, the energy extracted by the turbine will vary. So that is the main function of this, the working principle of the wind turbine actually. Out of this, there are three factors decides the amount of energy extracted by the turbine actually. That is the power, the simple empirical formula, power equal to of rho A V Q. There are three factors. One is the soft area, and another one is air density, atmospheric air density, and then wind speed at the height level. So out of these three factors, wind speed and air density is out of our control actually. So we cannot do anything. It's a nature dependent. So the only factor which we can control is soft area. The soft area of wind turbine actually, that the designer, the OEMs, original equipment manufacturers, will decide what would be the area required, or based on the market study, the prevailing market demand. So that will be decided. Now to meet the customers required amount of energy, so they can keep increasing the area, because the density and wind speed cannot be cannot be controlled by us. So the only factor is area. To achieve the required amount of energy, area is the only factor. So we can change as per our requirement actually. So the wind farm development, I just want to give you the stages of wind farm development, how the wind farm is developed, where we start and where we end. So like first thing, wind resource assessment and AEP estimation, which I am doing it actually. I have been doing all this time, and I know here also I am doing that. So wind resource assessment and energy estimation. So for that we need a process that I will be discussing actually mainly into. And the right side, you have seen some the schematic of the wind turbine, generator, the gearbox, low speed shaft and high speed shaft, the hub, consists of rotors, blade, all these things actually. This side wind resource assessment. The next one is project development. Once we say the resource assessment, based on the resource assessment, the energy estimation meets the requirement or meets the business requirement. So that will be passed on to the project development team, actually project development department. So they will prepare the rest of the things. Rest of the means site, that is land, required land, and then the evacuation infrastructures, and then the civil civil means foundation and suitability of soil, civil studies and all these things, approach road for logistics aspects. All these things will be carried out by the project development along with the pathway, everything including. So then once these two are prepared, the whole thing will be given to the business development team. So business development team, that is the sales team, they will approach the customer with these two informations, because customer will be ready. Customer is ready only to invest the money. He may not be knowing what is the policy, what is the amount of what is the energy, what is the site status, how much land has to be procured. All these things, all these information he may not be knowing or he may not require. He will just give. You will place the order. This is my requirement of 100 megawatt or 50 megawatt or 200 megawatt, whatever. So we have to give a complete turnkey solutions actually. So this is what industry is doing. Initially OEMs were doing original equipment manufacturers like Vestas, NEG, Micron, and this one Gamesa, Suzlon. Many companies are there actually in India. Indian companies, Suzlon, Inox, and some other companies. So they do complete turnkey. They prepare the site, they do development, they will sell the project and construct and over to the customer like that. So whereas now it is split into two. One is the original, the product, then rest of the product. That means the OEM wants to supply only product. The remaining things, EPC, they don't want to get into because of some complexity in the permits and getting permits and approval and procuring lands and local issues, all these issues. Now the industry is split into like this actually, a limited scope, a project kind of thing actually. One business development team will discuss everything with the customer actually. Then once business is through, it will be passed on to the construction actually. So construction will prepare all the groundwork. So they will start constructing the wind farm. Then next it goes to asset management. Once it is done, we have a asset management also in Everrenew. We do complete turnkey actually in Everrenew. So starting from site, offering site, development, business, construction, and then we have a separate dedicated independent asset management. So like that, the industry is actually, they are equipped with all these facilities actually. Some of the OEMs don't want to do complete thing, so they are supplying only product. The wind farm economy, general thing I'm just giving, the wind farm economy mainly because the investor invests his amount to get a profit. There are two things actually. Initially, if you see some 2000 before 2010, these projects were developed by only the captive power consumers. That means the traditional market, where the small industry people they want to use the power for their own industry, and through that they will get subsidy from the government and a lot of tax benefits. So a lot of tax benefits were there at the beginning. And now again, in between, after 2010, the independent power producer came into actually. So that means they are thinking, they think that this itself is a power producing company kind of thing, like a conventional thing, like a thermal gas based, coal based power plant kind of thing. They do 100, 200, 300, even 500 megawatt power and sell the power to the board or sell power to their third party kind of thing actually. So it has become a power producing industry actually. So obviously they expect a profit. once they invest money, they will expect the profit from the investment actually. So that's why what are the factors decides the economy of the wind farm? One, the site. Site is the raw material in this business actually, because the site means windy sites. Wind is the obvious factor to generate more power actually. One, out of this, a quality wind resource assessment actually. Quality wind resource assessment is a must, because site is good, wind is there, everything is there. Due to one or the other reason, for example, no sufficient data is there, or there is no more data like number of years, or the measurement is very limited at one or two places, but the wind farm area is very big. So these are the factors involved in the resource assessment, wind resource assessment. So the quality assessment has to be done, because based on that assessment only, the rest all will happen. Because the entire investment, for example, say 100 megawatt investment, somewhere around 800 crore rupees. 300 megawatt in a wind farm, single wind farm, somewhere around 2,500 to 2,700 crore rupees has to be invested based on this assessment only. So such an important task, the task is the resource assessment, wind resource assessment, that one. Once that is through, then selection of a product, right product. Okay, the site is good, potential, assessed thoroughly, done. But selection of product is very important, because the site is very good, but customer wants to go with his own selection, that the product is moderately efficient, or below the moderate. So we can do nothing actually. So selection of product also in terms of efficiency, in terms of safety. For example, a good high wind area, you cannot put a low wind turbine, because the turbine will fail, and this structural stability will not be there, structural strength, stability. So, and low wind area, if you put a very stable turbine, then it's a waste of energy, it's not actually money. So like that actually, selection of right product is a must actually. And then once those two are okay, finally the operation and the maintenance will come into picture actually, because everything okay, but the turbine has to be operated. When the wind is good, the turbine is stopped means maybe not intentionally, maybe some reason due to some mechanical failure or any other stoppages. So we'll be losing the energy actually. So this is not possible to store the source.
Ponduranga sir, your slide is moving. Wind
No,
farm
I'm not.
economy.
Yeah, not. This is no wind farm economy slide, no.
Okay, same one. Okay.
Yeah, I just want to give these three. Then after that, it will be so actually. So the proper operation and maintenance. Why? Because we most of them know actually. No, wind season starts from May onwards. May and the second half of May onwards. That's why in Tamil they used to call Adi Katha, like that. During that period, the wind will be very high. June, July, August, September, these 4 months, May off and October off, 5 months, that will generate almost 70 to 80% of the annual generation. During that period, there should not be any stoppage, major stoppages. Otherwise, the customer will be losing the energy. So these are the factors decides the economy of the wind farm actually. No, is it moving?
It's moving, Ponduranga sir.
Okay. Okay, grid interface. Now this is simple schematic actually, how it is interfaced, because wind turbine must be always connected with the live grid, because initially this works as a motor, you know that actually. Initially they work as a motor, it draws power from the grid and start rotating actually, it works as a motor. Once the sufficient the power is attained from the wind, from the wind, then it start exporting the power actually. So this is a simple this thing actually. Now this is the main area where we start actually. I'll quickly run through these things. I don't want to take much of your time. The identifying wind potential sites is the main task. How we do generally based on published data. There is some institute called Indian government institute, NIWE, Previously it was called CVET. Now it is called NIVE, National Institute of Wind Energy. They have conducted a wind measurement campaign across the country and published the data. So that data will help us to understand what is the potential at that any specific place where we want to develop. So these are the data will support us actually. These are preliminary level actually. Then suppose there is no data where we have identified sites. So we will look into reanalyze data through the numerical weather prediction and micro mesoscale data that is available in the public domain. So they have collected data from various sources like airport and the meteorological stations. All these things they collect and reanalyze the data and put it into the public domain, which is available to specific heights. Those are all only an indicative actually. So with that we cannot go ahead, but we will do some other one actually. The next step. Then operating wind farms. Operating wind farms, already the wind farms are operating. We know the efficiency of the turbine, the wind farm, any specific wind farm. Developing along or adjoining to the existing wind farm, there is no need of much study. That will help actually. Sometimes local inquiries. Even we also visit the site and see the site whether that site is suitable for development or. These are the basic actually details we do before we move on for further studies actually. I just want to show some animation how generally we identify sites and what are the main source to have a good wind. So that in this I have now put some animation actually. So you have seen some some flow kind of thing. These are all it's a pass actually in Tamil Nadu. This is Tamil Nadu area. Tamil Nadu sites, wind farm sites are developed behind the Western Ghats. The Western Ghats has a break. But there is a valley kind of thing actually. The wind passes through that valley actually. We are developing behind that pass. It has developed long back, even 95 also now government has put, Tamil Nadu Electricity Board has put, and many people have developed actually close to that area, close to pass. Whereas today we are keep moving further east of the pass, where by improving the efficient turbine, so we can extract maximum energy. One is the Palghat Pass. This is the one. Palghat Pass. I just want to show how this has been. So all this area, as you move towards east, the potential will be keep going down because this simple, the Bernoulli's principle concept, convergent divergent concept actually, the upstream wind converged towards the narrow area and then diverged behind that area actually. So the projects are installed behind that the narrow region actually. So where the velocity will be high, and as we move towards east, the velocity, wind speed will be keep going down. To compensate that we have discussed, to increase the energy, we have to go for bigger rotor diameter and a higher hub height level actually. So this is just a small animation. And then the wind monitoring, once sites are identified and then we have decided to go ahead based on the preliminary studies, based on published data and other sources of data. So once decided, further we need to go, because as I said, this is a huge investment in a single project. It somewhere around 1,000 to 2,500 crore rupees will be invested by any developer. So we need some very quality and there should not be any uncertainty in the measurement, or there should not be any uncertainty in the assessment. Such kind of data should be collected. So we'll recommend for wind mast installation. It is a meteorological station, consists of some sensors and other instruments actually. One is the mast recommendation, selection of wind mast locations, and the instrument and measurement heights, what height to be measured. Then monitoring the wind data, it is important because we need a continuous data. All 12 months is not same. climate or atmosphere wise. So every day the climate or the this one condition, atmospheric condition changes. So so we have to same way we have to have a data throughout the year without any major break. 1 or 2 days, okay, but not long break. So that that will mislead in the assessment, that we should avoid actually. So that's why we will will go for online monitoring. One of the team will be keep monitoring how it is working across the country, the med station. So then data collection and quality control, and that data analysis and energy estimations. So this is the process actually in the energy assessment. Wind monitoring, where to install the wind mast, that is most important, because in the top if you see one slide, that is a plain area, whereas in the down it is a complex area. Plain area will have a uniform wind to the maximum extent actually, whereas complex area, the site is undulated, the wind we cannot predict so easily. So this is very, we will go for the CFD based assessment actually, computational fluid dynamics based assessment, to have the resource grid. You can see that the second map with the red color, that is that is the resource grid map, where the wind is high on the red area and the blue is the lowest area. So these are all little confusing and very meticulously to be carried out the potential assessment. So this is the one. And we have to see while installing the mast, is there any nearby obstructions, and what is the extent of area is available, access to the site, and then any nearby dwellings. All these things has to be taken care while installing the mast itself. This will be done. This is the process. I'm saying again and again, this is the process they followed in the industry, irrespective of any company or any OEMs. This has to be followed to develop and to have a successful wind farm. So this is the one wind monitoring campaign. Some of the instruments what you use, you can see the left side one tower, tall tower with a thin standard cross-sectional dimensions with a 130 meter, 140 meter height. Actually, it is almost a 400 feet height actually. So much is the hub height level actually. According to the hub height means what is it? Where the NASA has been kept at that height. That much height mast has to be there, because we don't want to extrapolate the data. That I will explain in the next slide. Some of the instruments, anemometer, wind vane, and then the data logger which collects the time series data. This is the diagram which shows the wind mast fitted with the sensors at a different height actually. Why we are fixed? Why are we fixing sensors at a different level? To understand the velocity profile with respect to height, how the wind speed varies with respect to height, because at certain height the wind speed will become free stream wind speed. That's the boundary layer. That is the where the wind speed become constant above the boundary layer. So that height we have to understand. There is no point in going further that height. And again, when you go down, there will be huge variation. And because when the blade rotates, the blade comes at the bottom position and also it goes at the top. Between bottom and top, there will be huge variation in the wind speed, which will create a fatigue to the turbine blades. So that to avoid that, we have to find out some optimum hub height level. So that the reason the sensors are fixed at a different height actually. And also we follow some standard, international standard, IEC, International Electrotechnical Commission. So they have given the specification to conduct the measurement. Accordingly, this will be done actually. This has to be followed, and that will be verified by the government national institute and some external third-party agencies actually. And this is what the empirical formula to get the wind speed at any height. For example, those days, if you see it before 2000, even around 2005 till 2005, there were no taller wind mast actually. So only 20 meter, 50 meter. If the 50 meter mast is there, sensors will be connected at a 40 meter and 50 meter level. So we want to go for 80 meter hub height, means these two data, the measured value will be extrapolated to the 80 meter level. So the formula says V1, V2 known wind speed at a known height. From that you will get the shear constant, power law index it is called. Using the natural logarithmic formula, taking the ratio between the heights and the wind speed and the heights, so we can get at the next level actually. But this will lead to the uncertainty because this is the empirical formula. It's a linear extrapolation actually. It is not the actual thing. So that's the reason we are recommending for the mast height at the hub height level. The turbine height, what is the turbine height? At the same height, the measurement has to be conducted. So that is the thing that I can show in the next slide. So the case study between the extrapolation by empirical formula and then actual measurement. The rows, the pink one shows the extrapolation by the formula. That means at 100-meter height, just 1 minute. At 100-meter height, the wind speed is somewhere around 8.6, 8.7. But actual measurement, this is the actual measurement curve. Actual measurement is little less than or somewhere close to 8. So this will lead to a lot of uncertainty in the energy estimation at the end. So that's the reason the industry is mainly targeting the hub height level measurement, so that to avoid any extrapolation. Extrapolation is always an extrapolation. So that will have its own uncertainty actually. So it is because the cost is very, very, very minimum, peanut cost for conducting these measurements compared with the investment cost, not even 0.1% actually. So no industry will hesitate to put money and time to do this complete assessment, because this is the primary thing for this business action. So this is the thing. Now monitoring campaign. The entire thing will be monitored sitting at a corporate place or any one place anywhere in the world actually. So you can directly interact with the metmast and see how it is functioning, what is the conditions, wind conditions, instantaneous values at any time actually. So this gives the more confidence actually to the team, resource assessment team. So the various functions, data collection, periodical analysis. So those days, if you see before 2000, there were no such facilities. Even till 2005, I think 5-6, there were no modem and connecting with the data logger and seeing the online, seeing the instantaneous status of the mast. So once if there is any discrepancies or any malfunctioning in the mast, then the person will visit next month or after some interval. That time only will come to know there is an error or there is some malfunctioning. Until then, there won't be any data, or the data may not be useful for assessment actually. Whereas today, if you instantaneously you can see any number of masts across the world actually, and you can do that across the country and wherever you want. You just connect whenever you want, see how it is working, and then suppose if there is any malfunctioning, you can immediately put to the team to get it reinstated actually. Other one, deviation could be addressed actually. If there is any deviation due to the malfunctioning, that can be addressed. All these are the advantages today actually, or these are the strength to do a better quality assessment, energy estimation, that will give confidence to the investors actually. And this is just showing the data, how the data is collected, how it will be presented, time series data for the 1 year period or number of years, or even split actually, because those days we need to have a 1 full year, because all the 12 months are different in terms of the atmosphere and the climate and everything. So the condition vary between the months, between the day even, but 1 year we have to be there. Whereas today, even partial 13 months, 14 months, 15 months data, 2.5 years data, because now the process is different. The measured data will be correlated and predicted in a long-term data actually. So the concept has changed totally. that gives more even confidence to the investors actually. This is the data, and once sufficient data is collected, this is the analysis result. We can quickly understand how, I told you that how wind speed varies with respect to height. As you go higher and higher height, the increase is less. From 110 to 120, only small increase. Further 120 to 130, still less. So like that, these are all the no the factors we will quickly go through and then decide further development. So whether the site is performing as we expected in terms of the potential, as well as the total gas one actually the energy required. Then this is the predominant wind direction. This is the direction frequency. What is the predominant direction? The maximum amount of time wind comes from southwest direction. This is west actually, southwest direction, and accordingly the wind farm will be developed. The micro siting will be carried out, because if you are developing only one, if you are installing only one machine, you don't need to worry about any direction, because machine has the facility to, yeah, it can rotate 360 degree, but if you are going for second turbine and the number of turbines in a wind farm, then where to put the second turbine, that's the matter. That's the big deal actually. So we need to have a quality direction things, because wind will be there, everything will be there, just because of human error in a direction. So that will have a huge impact on the energy for the wind farm. And once it is passed, means it is ever forever actually. But if we wrongly did means, because after that we cannot move the turbine and anything, we cannot do anything, we cannot even adjust. So that's why that has to be very carefully analyzed and so likely. Then this is the seasonal variation. I told you that starting from May until September and October, the energy will be peak. The rest of the months will be the normal actually. So this will give you some idea actually. And this is between the day, in a day, diurnal wind speed actually, in a day where the wind starts maximum and where it comes down. If you see that evening 6 o'clock, the wind goes high. This is the one of the Tamil Nadu side, I think. So the wind goes high. Based on this one only, the storage system had come into place, because the demand will be somewhere here, but we are producing 6 to 10. Okay, this is fine. Tamil Nadu side, one side, fine actually, 6 to 10, because evening 6 to 10 also the demand will be high, and morning 6 to 10 the demand. They have put the slot wise power demand by the ministry or the discoms. So based on that, if you supply power, then you will be paid more. The tariff will be high. That's why this energy storage system had come into place. So you will store the power and supply whenever there will be a high tariff. That's why before that I just thought I will give all this information. Then we will go to the storage things actually. This is very important actually, because we will club this with the solar. This is the wind diurnal profile, and solar. If you see morning 6, 7 or 8 to evening 4, somewhere around 4:35, something like that. During that time the wind will be low, but that time only the solar will be high. So this is the apt site actually. We can combine both to do the hybrid project, wind and solar hybrid. So we'll one side wind and one side solar. When wind generates, solar will not be generating. When solar generates, where the wind is low. So that is the advantage this site has got. And then still, if there is a gap, that has to be addressed. That's what we will be doing actually next. This is the frequency distribution, just to understand how it is. The bell curve shows. If it is close to the y-axis, the frequency is more, means the potential is less. As we move, it is away from the y-axis, so the site has got good potential. We can quickly decide all these things actually based on this. And month-wise, as I said, that the 5 months will be southwest or west, based on our country position on the earth surface, earth. So for Indian terrain, the predominant wind is southwest or west throughout the Ind, starting from south to in the extreme north, because we are between 7 degree to 32 degree polar zone actually. So for that, these 5 months is the main thing actually. May, June, July, August, and September. After that, October, the wind direction changes to east. So this will help us to understand, the significant the of microsighting actually. I told sometime actually I told you that we have measured few months data, maybe one plus year, 15 months, 18 months data. This is the measured data. There are some other data source available in the public domain, that is long-term data. That data is the measured data is superimposed with the long-term data available in the public domain and correlated. So based on the correlation, we will get some R square value, regression value, how best it matches with the long-term data. And then we extrapolate for 20 years based on these facilities were not there before. So the last recent few years, the system actually this technology had developed to do that. That will minimize the uncertainty in the data actually, because you would have seen that in the last 2-3 years in Chennai also 2015 had seen extremely high rain. But before that, just 2 years before, it was like anything, dried like anything. Chennai, there were no water. I think this one water at all. In I think 13 or 14 something. I do not remember. So like that, based on 1 year, we cannot actually decide. This is the standard of the conditions actually, the rainfall or the dry condition. So that same thing applicable to the measured data also. Based on 1 year data, you cannot decide actually. So we have to go with the long term. Otherwise, this MCP, measure, correlate, and predict concept actually. The below is the after correlation, the measured data superimposed with the long term data available in the public domain, how it will be. So that when you use 10 years, 12 years, or 15 years data, you will have more certainty in the energy assessment actually. So now, wind monitoring campaign, after that, the estimation, generally these are the products available in the market. So Sloan, some of the company actually, and then the Enercon, Envision kind of thing actually. Turbine specification, these are all turbine specification. We do energy assessment for these turbine. These are all predominantly available in the market today. And all these OEMs, either they do direct turnkey complete project or supply and support for the development. So this is the power curve. Once for any the efficiency actually, for any product there will be efficiency curve, how it will how efficiently it will give output for the given input, like that. This is the power curve for a given wind speed. What would be the expected power output for this turbine? And this is a theoretical value given by the designer, the R&D team of the company, and at standard air density 1.225 actually 1.225. This will this will be the reference to do the energy assessment. And then gross level, next level, the at the net level, all these things will be done. So MOST is installed, data is collected, quality assessment done, and the power curve, using that power curve, the measured place. You have selected a site. We have selected a site and WindMOS installed and collected data for 1 year period. After 1 year period, what would be the energy estimation at that particular place? This is simple, simple arithmetic to get the energy estimation. Just X into Y equal to Z, something kind of thing. Actually, it is like that. This is the number of occurrences actually, and converted into frequency distribution. Frequency. So much amount of time wind is blowing between this interval, 6 to 7, 7 to 8, 10 to 11, like that it is. Occurrences converted into frequency, and the power, you have in the previous slide you have seen that power curve. This hours into the power curve, the kilowatt multiplied. So kilowatt hour. If the wind speed is continuous for 1 hour time, the power will be kilowatt into 1 hour time. You will get the kilowatt hour. This is the kilowatt hour actually. So this is the estimation at the master position where we have measured. We have done the estimation. So this is the amount of energy. But after that, there will be some correction factors because this is a gross level energy estimation. After that, air density correction, machine availability. You cannot expect 100% machine available. This one actually throughout the year. There will be some scheduled maintenance, unscheduled maintenance, some breakage. All these things will be there. So 3% or 4% according to the commitment by the supplier, actually the machine supplier. That will be there. And the grid availability also. Grid, we cannot expect 100% grid. There will be some outage. Also like that, so many corrections will be applied. And wind resource assessment, wind research department related actually corrections will be there. These will be decided by them based on some parameters and factors. So then finally they'll arrive P50 net generation. P50 means whatever we give generation, there is a probability of achieving 50%, 50% amount of time. So you will get that generation. Remaining 50%, there is a possibility to go down or even more also like that. Suppose someone wants to have a more certain values. That means probability should be more actually. Achieving the results should be more. P75, go for P75. The number will come down. 12.56 has become 11.68. You will give lesser energy. Like that it is actually. These are all actually investors' point of view. We have to give the numbers so that you will take less risk. They don't want to go more risk actually. What is the worst case? We will be ending up with the loss like that. They will decide actually. So just I want to recap. So we have just discussed renewable energy, the basics, and then wind turbine working principle, site identification, then wind mast selection, mast installation, selection of sensors and heights, fixing of booms and instruments as per IEC standard, data collection and online monitoring, quality check and data processing, data analysis, finally generation at the master position. These are all we have covered. So now we have another, we will take, now I will complete it quickly. So now I will be, I'll run through the energy estimation for the wind farm level and the feasibility factors. What are the input files and all these things not now required much. That will quickly move. And then the energy storage actually, that will cover next. Professor, is that okay?
Okay, sir. Yes, okay. Continue. Okay, Ponurangam sir, let's continue.
Okay, fine. Thank you. Yeah, micrositing. So we have conducted studies or we have discussed what is the wind potential at any specific site at a particular place. So that you have measured wind speed at a different height and then for 1 year period, and that should be a representative. Then you are measuring the wind speed that should represent for the region. You cannot say out of 10 the highest value as a sample or the lowest one. That is not right actually. So representing the whole area, that has to be there. So with that data, we have to develop an energy estimate, or we have to do energy estimation for the whole wind farm. This is the factors actually. Estimating micrositing actually means you will be putting more into focusing into specific location and specific turbine. What is the energy like that? Estimating energy production for any specific turbine at one or more specific locations, because each location will have its own uncertainty or its own disadvantage that has to be actually addressed. These are the things actually. In the process, what are the major obstacles, and then the factors, which are economic factors like approach road should be there, T&D losses, then accommodation, HT line cost, etc. All these things will be thoroughly studied. Initially we do. After that, they will exactly quantify what would be the T&D loss for the wind farm, transmission and distribution loss, accommodation cost. If you put engineers at the site, how they can operate from all these accommodation, other facilities to be done, and the HT line cost, the high tension transmission line cost, All these things will be there. Then environmental factors is very sensitive because visual impact not may not be high here because we do project development in the remote area. So not very sensitive, but still it is a cost actually. It's a constraints actually. Then bird sanctuary. This is very sensitive. Sanctuary should not be there. The development area. There's a lot of government restrictions there, and noise simplification also. Near to the dwellings, it will not be allowed. And then any parks and dwellings, all this that will be studied in depth before developing the wind farms. Then institutional factors, usage of land, state policy, then the boundary, limit to safety. All these factors will be thoroughly studied. Everything recorded, everything a report will be presented for all these factors. Then only the investors will be discussing further, the negotiating and coming for the contractual discussion actually. So meteorological hazards like high temperature, extreme winds, these are all taken care. Like along the coast, if you go close, there will be cyclone prone zone. There we have to be, especially in the Andhra belt. We see Machilipattinam, Bhuminipattinam, and this Chandipur. Along this, those kind of things has to be kept in mind actually. And then the location, wind turbine locations must be optimized by visiting. If required, if it is a complex terrain, make a visit and see how the locations are spread across. So then, and there is a thumb rule. Every state has got a thumb rule. The wind farm has to be developed in certain manner. The distance has to be maintained between the turbines. For example, this is the between the turbines in a row. This is one row with respect to predominant wind. And this is the second row and third row like that. So between the turbine, some distance, and between the row, some distance actually. I am seeing that this is the proper microsighting actually, because wind is coming directly from west. It passes the turbine, and this is behind the turbine, the wind is disturbed. When it goes to next turbine, there is enough distance actually. Again, it will become free stream wind. Completely not, to maximum extent, it will become free stream wind. And then next turbine, again, the wind will hit the next turbine. Like that, it will happen. Suppose the turbine is placed instead of here, if you move here, then you will be losing 30 to 40% amount. This turbine will lose 30 to 40% of energy because the wind itself is less energy wind. So like that, that is the reason the direction is so important actually in this process. So you can do that. Yeah, energy is there, but because of not properly doing the the microsighting or placing the turbine, so obviously the loss will be to the investors only. So public roads, distance, all these things has to be maintained as per the government policy laid down. And this is the input files to do the energy details. This is the terrain elevations, and these are the reference. The line shows the there the major obstacles are there within the area like that. It has got some sensitive actually. When wind passes through that, there will be some obstruction. There is a drop in the wind speed, something like that actually. The software required all this information. And then once you give all this information, by selecting the turbine, you will get energy estimation at the each and every locations. The locations are given in the latitude, longitude, in this case Cartesian coordinates, eastings and northings in the meter actually. These are meter in the different form of lat long. Lat long is standard form actually, latitude, longitude. This is in the Cartesian coordinates format actually, in the meter form. So once you give the coordinates, by selecting the turbine, so you will get energy estimation, what is at the each and every locations like that. And there will be some loss and array efficiency, everything will be there. This is now we have calculated energy estimation for the whole wind farm. Annual energy production, how the results from modeling will be corrected for further correction, applying correction factors, standard loss, AEP, gross level, wake loss, other losses, finally P50 net. When customer wants to go for P75, less risk, P90, further less risk, there won't be, hardly you will have only 10% less risk. Like that, the values will be estimated actually. This is the thing actually. Finally, this is the wind farm. Just animation actually. So the wind farms will be pooled to the pooling substation actually. There will be a substation in the wind farm itself developed by the developer to the individual customer. Suppose if they want the entire wind farm, there will be pooling substation. From the pooling substation, the voltage will be stepped up to the GSS, the government substation voltage, then linked with that actually, interfaced with that. And now wind farms clusters through the VCB, and it will be connected feeder wise, and finally the from low well to this is a PSS actually, wind farm level pooling substation. From there, the transmit power will be transported to the utility substation. So this is the typical wind farm, and now we'll move on to battery energy storage system, BESS. Storage, I think yesterday also they have covered storage. Only two type of storage. One is the battery energy storage. Another one is the pumped hydro. This is what the government is calling pumped hydro. This battery energy storage is energy stored in the form of energy, actually power. Whereas pumped hydro storage, you are storing the raw material, water, air, and whenever you require, you can generate power like that actually. In this case, energy, you are storing the power so that whenever you want, you can release from the battery actually, straight away release. So it's a matter of no time. You just open and you can discharge the power from the battery and supply. So like that actually. So wind farm separately developed. Solar farm is separately developed. Wind and solar, there are some policy says wind and solar will be given a better tariff combining these two. That is called a hybrid project. After wind and solar combine, still there is a gap in the power supply to the demand. Then this battery come into place actually. So battery is the readily available power actually. You can any moment you can just open and supply and close it like that actually. So this is the one. I have some few case studies. Almost I'm nearing it. Few case studies how this has been operated actually. This is now only we are coming into the energy storage generation. Whatever we have generated in the last few slides, whatever we have discussed, you are generating power. Certain amount of power you will be getting, and the demand generation is more than the demand. This is what a demand, but you are generating more. So what you do, one thing, solar, wind, hybrid together, or wind alone, or solar alone, whatever you can do. This is renewable energy source generation, and generation is more, and you will not be to them, and you can use the excess power to charge the battery. So this is one case. So whenever you require, you can pump through like this. So you can discharge and go like this way. So generate, supply the power, and that demand is less, and the remaining power you can charge at your battery. This is the one case actually. The next one is generation, again more than the demand. Now battery fully charged, still there is an excess power. Now you can supply to the grid. But all these, there is a process, power purchase agreement. The government is entering into a power purchase agreement. This is what the price will be given, and accordingly you have to supply. The demand, you are supplying more power here, then that power will be given at 50% rate, whatever the agreed power. For say 3 rupees 80 paise means you will be given only 1 rupee 90 paise. So whatever you give excess power. So the excess power you will get only 50% of the agreed PPA, power purchase agreement tariff. So this is another thing. Case 3. So okay, now generation is less than the demand. Suppose you do not have sufficient power to supply. There is now you can discharge and supply whatever the required power. That's why we are charging power. We are charging the battery and keeping ready. So this way we can meet demand. Sorry. Then next is generation is less than the demand. Battery discharge, still there is a gap. You could not meet the demand. Then this is the G dam, green day high-end market actually. Green day high-end market it is called. So you can purchase 5% amount of energy from the grid. So from the grid and supply. So with that, still you will be getting your agreed tariff actually. Green day high-end market actually. So this concept is allowed up to 5%. Suppose there is a gap still. You are not meeting beyond the day of the demand. That is beyond the 5% means you will be levied penalty. Huge. How much? 1.5 times the agreed power actually. 3 rupees 80 plus 190. So much penalty will be there. So pay LD, liquidated damage. This comes into the case. These are the various storage system. During this process, the industry will meticulously sizing the capacity. Wind how much, solar how much, all are cost involved actually. Huge amount involved. So wind how much, solar how much, and battery. Wind is, for example, say wind farm per megawatt cost is somewhere around 8 crores, I can say. It is not exactly, somewhere around. It depends upon the turbine. 8 crores. Solar is 4 to 5 crore per megawatt. Because energy is varying, efficiency is varying. And then battery is close to 15 crores per megawatt hour. So like that. So you cannot just simply add something and keep another thing less like that. So these are all to be closely monitored and sizing has to be done carefully according to the demand actually. So this energy demand versus available wind and solar. This is the demand curve actually. This demand is fixed across the country. Some demand is like this, and this is everywhere. Now energy varies between the place. Like in Gujarat, this is the energy, total energy. This is sum of demand, and this is the total energy available. And Tamil Nadu one side. Now you are clubbing with solar. Solar is like this actually. Across the month, every day there will be some plant load factor, some percentage of amount of energy will be available. This will be clubbed, and then your demand will be met, maybe little lesser or more like that actually. And this is the solution before and after hybrid BESS, battery energy storage system. Actually, by clubbing the wind and solar, this is the demand. In the previous slide we have seen, this is the demand. After clubbing the wind and solar, this is how your output will be. Still there is a gap here and gap here. This can be adjusted by releasing the storage system. Here only the battery energy storage system come into place. So this will be addressed at this place. So demand is meeting with hybrid BESS. So this is what I have got actually. So I hope I had given some takeaway.
Professors, any questions? Is the question? Yeah.
Sir, Panduranga sir.
Yes, please.
Sir, sorry, I'm Dr. Purushothaman. I'm one of the co-coordinator.
Yes,
I have one doubt. I think we are developed in our college hybrid solar and wind, but the power will be getting a different way. How to match this for before charging the batteries? Is there any instrument to mapping, equalizing the power output from the hybrid, solar and wind, sir?
So you have installed turbine inside your campus?
Yeah, we developed before 3-4 years. We
Okay.
run only one fan in my HOD rooms when I was in HOD. But now this collapsed due to the wind. Okay, but we face the problem for how to mapping this output from solar and wind, because the different for night we are getting the more power from wind. For day we are getting the sun, okay, solar. So, but different, I mean, the power output from this both unit. So, but
you
we
will
want,
have a, yes, sir. You will have a metering. No, the recording will be there for every hour. What is the output from each source? From wind,
but
separate will be there.
yeah, we measured the voltage or current, both.
Uh,
But you have to synchronize and charging the battery. That is, we have faced some problems during before 3 years. We have developed the project by our
okay,
students.
okay,
Is there
okay.
any instrument to synchronizing
Uh,
the both
Yeah,
powers?
it is possible actually. We the
Uh,
micro turbines generally the 1 kilowatt, 2 kilowatt turbines, no, not producing much. It is somewhere around 18 or even 18%, less than 18% efficient actually. And solar, okay, that is 20. Again, that's also in the same level. But net metering kind of thing you can use actually to club these two and charge the battery, because whatever you generate power, you may not be directly consuming, but the demand is very high. Here, the output is only small. But in general case, no, the rooftop, solar and whatever we are installing on the top of the roof or the ground mounted. Government is
yes.
giving some subsidy now. There, what they are following net metering. So
Okay.
whatever you produce, you can consume or you can export. Whatever you need the power from the grid that you can draw. Finally, the net meter will take care what is exported, what is imported, put together, including the storage.
Oh,
So you will
yeah.
have definitely a battery. So
Yeah,
that
yeah.
will parallelly will do that. So clubbing these two, it's a matter of some small technical it's one actually clubbing things only. So that is possible actually.
Because for any house we can use both no, solar and wind. Maybe it's in the future you can use for small scale
No, 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 no,
hybrid
no. No,
combined.
no, no,
Right?
no, 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 sir. No, 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 no.
It's not possible.
Not possible. Not technical aspects. Not in the technical angle.
Uh,
The wind, no, installing a wind turbine, micro turbines, it will be very risky. It needs, because the turbine will be keep rotating. The dynamic loads will be very high. It may damage and it may, create some safety issues. Solar is not a big one actually.
okay,
Anyway, on the top rooftop, whereas wind, that's why wind is not allowed. Even very strong building on the top of the strong building also there will be huge vibration actually.
no, the
And
power
so
demand is for the individual house.
yeah,
Can you?
no, not even individual house also it is not allowed. And we have experienced in the previous
Oh,
company when I was there,
okay.
that was not discussed actually properly. And then it's a strong, very strong building, eighth floor or ninth floor actually. On the top of the
Oh,
eighth floor, it
okay.
was installed, and they have experienced severe vibration actually in the ground next level, next floor level. So
Okay.
then they complained, and finally that has to be removed. We have removed it actually. It's
Oh,
in two places I've seen. The previous that company also.
yeah, yeah,
There
yeah.
also the same thing I experienced. And this domestic area, safety is very much required actually. Suppose something goes wrong, if it breaks, because these micro turbines will have a variable speed RPM actually, rotor RPM.
Okay.
So that may rotate even 30, 40 revolutions per minute. So that will have suppose if there is a break, then that will create some this thing actually.
Oh, okay. Thank you, sir. Thank you.
So that kind of thing is there.
Sir, Punaragan sir, there
Yes,
is some
yes,
question from a chat box. Mr.
yes.
Muhammad Hanif.
Yeah.
The question is, how accurate was the prediction of wind energy using CFD versus real time? How accurate was the
Okay,
prediction of wind
okay,
energy
okay.
using CFD
Uh,
versus real time?
okay. CFD is mainly for complex terrain. So I told plain terrain doesn't require any CFD. CFD based, you will be the iteration will be very high in the CFD based assessment. The software will be different to do the assessment. Prediction is a prediction only. That's why either the linear modeling or the CFD based modeling, whatever you use, the less uncertain will be in the linear terrain, plain terrain. In the complex terrain, even if you use CFD based model, the measurement is not representing, or it cannot represent all the location, in a complex terrain. Then few locations you may see the equal amount of, or the whatever the theoretical estimation and the actual generation matching. And some locations will have gap, some locations even will have a huge gap. So it is very difficult to tell actually. These are all very dynamic, the numbers. So we cannot say. That's why plain terrain. But now there is no much complex terrain available in country. So those are all exhausted. Now this one simple the linear program. This one linear modeling only used to do that. With that, you can say 10%. Even 5 to even less than 5% only industry is accepting, investor is accepting. You cannot give anything beyond 5% drop. Then there will be some penalty or penalty clause will be there. 5% is acceptable because we cannot say the nature. No, it is only prediction. So much wind will be there, so much energy you will get every year, like that we cannot say. All are estimation. It is only an estimation with due uncertainty.
Yes, sir. Another question from my side. What are the career opportunity research opportunity for this field, wind energy field?
Yeah, see, two area is there. One is the product area, another one is the development area, EPC. Product area, there are a lot of development is happening because they will be keep increasing the rotor diameter, and then the generator side. Even recently, I had a discussion with the team. They said that there are two types of generator. You know that electrical people know that induction type and the synchronous type. Induction type, there will be wounding coils. So dual windings will be there actually. Low speed, high speed winding. So doubly fed winding. Instead of the winding, now they want to put a permanent magnet. To the induction type, a permanent magnet. Like that, a lot of research is actually keep happening. So opportunities are there, and again, this opportunity will be throughout the world. Because almost all the countries, no country is saturated except a few small countries, European countries like New Zealand, Switzerland, and Denmark, Holland. These people, they do not have sufficient place to develop ground. This one, the land mass. So they go to the sea, and they develop. No, they want to achieve 100%. That will be done in a short period, actually, like that. So. Lot of opportunity will be there. One side development R&D side, another side everywhere the project has to happen. Civil side demand is there for construction and the land development and everything. Another thing, evacuation, infrastructure development of substations at high voltage level and HT line laying kind of thing. Another next is this thing actually, the operation and maintenance and quality area. So huge opportunity will be there down the line. Even in India also, because our target only 2/5 of the target is achieved, 200 mega, 210 out of 500 target. So not at least not at 500. At least we will reach another 200, close to 200 in the next 6 years time. So lot of opportunity, job opportunities are there, and even business opportunities are there actually.
So, any other questions from participants?
Yes, sir. Hello.
Yes,
ma'am.
yes,
Hello?
madam. Yes, madam.
Yes, madam.
Sir, yeah, just one question from my side. If we are, if we, actually, I have done a project in vertical axis wind turbine in my PG. My side one question is there is possible to connect the micro vertical axis wind turbine in series in the series way, and where we can use the power to be in the commercial plots. Is there is any law from the government side to be maintained?
Actually, the vertical axis turbine, not
Yes.
very familiar here. It was there actually. But the installation cannot happen at the no the settlement area, dwellings area, because safety is the matter. And again, as sir said, on rooftop again this also will have a vibration because according to the wind,
Yeah.
the turbine will have this one actually dynamic loadings. So dynamic loading means
Okay.
it is just a vibration. So that cannot be,
Yes, sir. Yeah.
that cannot be absorbed or controlled. So it will be difficult. No policy is there as of now. No policy is there, a government policy, and especially for domestic, usage, it is not at all allowed. It will not be safe also because you can put
Okay.
you can put we say for example we have an independent house, uh, we can
Yes.
put on the rooftop, but what about the neighbors safety? Who will give and who will monitor all these things? Even for developing wind farm, there will be lot of safety procedures, trespassers,
Okay.
local settler dwellings, the people from the local dwellings and settlements. All these
Mm.
things has to be kept in mind actually, their safety of the no locals. Whereas
But,
here, government cannot monitor all these things, and with the investors or the people who installs, they are interested. But what about the safety of neighbors? That will come into picture. Whereas solar, it is straight away given. Now everybody is installing actually, and government is giving, central government, state government is giving subsidy for the solar up to 1 kilowatt, 1.5, 3 kilowatt, and using net meter, you can whatever you consume power and whatever you export, difference will be taken care actually.
okay, sir. Is there a possibility to construct our own BAWT and we can, yes, of course, I understood the what and all the background, what will be happened after the installation. Is there is any possibilities of, according to the law where it
Yeah,
is
you
followed
can.
in foreign countries?
See, the government won't stop. There is no policies to stop. If you are owning a land which is no away from the dwelling settlements, and you have a completely covered area, you can develop. You can put it.
Okay.
Say the land, the farmland. Now solar
Yes.
water pump has come. But the
Mm.
same way you can put the vertical also. But in the large scale, you have to think whether it is
Okay,
possible
sir.
on the large scale. Many micro level turbines and small things are happening, but in the large scale business, that will not be possible actually. But you can, but
Okay.
no stop is there actually. To my knowledge,
Okay, sir.
there is no any stop. Any policy stopping that actually. Even micro turbines, sir was asking, micro turbines, even you can put on top of the roof. Safety only.
Yeah.
Government won't stop, but someone, the neighbor will go on this one because noise will be there. Huge noise will be
Okay.
there, and the vibration will be there, and then that will be very no the this one also shadow effect and the visible nuisance also will be there actually.
Okay. So could you
So
help me in this if you have any idea about this?
sure, madam. Sure. Now I'll check and update you, get you back.
Okay, sir. Please help me in this project too, sir. Actually, I'm into this.
Okay.
Mm. For future concerns, please put your mail ID or for further reference, sir.
Sure, ma'am, sure. I will share with Professor CHINNAPANDIAN, and you can take from him actually.
Okay, sir. Thank you.
Sure. Okay.
Uh, so any other questions? Probably the last questions from my side, Mr. Ponnurangam.
Yeah.
What about the offshore wind farm and all government has announced? What is the status of that offshore wind farm?
Actually, offshore wind farm along the Gujarat coast, they have conducted as this one. The study has been conducted by the government itself because installing a measurement tower, wetmast tower inside the sea, it will be very expensive, very expensive. It cost crores actually, and monitoring, control, everything, because coastal regulation also is there, restriction is there, so it will be difficult. But government has completed the study. Potential also they know that actually it is not published. And second thing, they have they called for tendering, that is seabed leasing. So they are giving sea in the Kanyakumari belt area, square kilometers, for every square kilometer, 4 lakh rupees per annum, like that. Something I had a personal discussion with the team actually. Through that I came to know, but it is not completely, no one, or it is not actually progressing, because why this is not progressing like a traditional or offshore, the onshore wind, because we do not have a crane to install a turbine inside the sea today. Whereas the European countries and Western countries they are doing it, because they don't have spare land mass. They have to go to the sea only. They are doing it. Whereas we have sufficient land. At least for next few years, we will develop. Parallelly, the study will come. At least 5 to 6 years, or next to 6 to 8 years time will take to make it possible in the offshore wind farm actually. Study again potential, the investment cost or the development cost per megawatt. I said in on onshore wind farm, 7 to 8 crores per megawatt cost, whereas at least 2 times will be costlier in the sea, like that. So financially, I do not have exact numbers. I'm just giving rough numbers. So much expensive offshore wind farm, and then the energy will be no expensive. Will the government take so expensive power, whereas other side the power is cheaper? So like that it is actually.
So okay, really wonderful. Mr. Pundurangam, you have given
Yeah.
insight to the wind energy, how to identify site and all, how to estimate assessment. You want to make a farm in a wind farm, a particular place. Everything you have told very clearly. I think our participants have taken well.
Yeah. Thank you so much, Professor, for giving me the opportunity, and especially the participants. So I tried my best.
Formal vote of thanks will be given by Mr. Mohammed Ghanib. Yeah, Mohammed Ghanib.
Yes, sir.
Yeah, please give now vote of thanks.
Sure, sir. Good evening, everyone. It is my privilege and honor to propose the vote of thanks at the conclusion of this enlightening faculty development program. First and foremost, I extend my heartfelt gratitude to our esteemed speaker, Mr. T. Ponurangam sir, for sharing your valuable insights and expertise. Your words have truly inspired and enriched us, providing new perspectives that will help us grow as educators and engineers. I would like to thank the organizing team, Head of Mechanical Department, Dr. A. Shadrak Jayasekaran sir, Coordinator, Dr. M. Chinnapandyan sir, and Co-Coordinator, Dr. K. Purushothaman sir, and my dear faculties who have worked to ensure smooth execution. Your efforts in planning and coordination have truly paid off. Your dedication to faculty development is commendable. Lastly, I extend my gratitude to all the participants for your enthusiasm, active participation, and meaningful discussions, which has contributed in various ways to make this program a success. Once again, thank you all and have a wonderful day ahead.
Thank you so much.
Thank you, sir. Thank you,
Thank you,
Ponurangam,
sir. Please
Participants, please unmute your video.
for taking photos. Okay, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir.
Record நிறுத்திடுங்க.
That's right. So, for tomorrow, session starts with Dr. K. Karpasamy, Assistant Professor, Senior Grade, Department of Mechanical Engineering. He is going to talk about transportation energy storage for sustainable future. And then next second session, Mr. M. Somasekhar Nayak, General Manager, Hydrogen Engine and After Treatment Mobility Group, New Energy Initiative, Reliance Industries Limited, Bangalore. So, so kindly come in on time. So tomorrow we'll start by 6 o'clock. Thank you all.